Hello again, all you beautiful, wonderful people out there in Blender and NumPy land. Time for another tutorial, and I hope this is amazing and it lands you a multi-billion-dollar job where they shower you with gold dust every day and you keep your eyes closed because it would really sting if it got in your eyes. So today we're going to talk about, hopefully what I promised I'd talk about in the last tutorial, which was logical indexing a little bit, we'll review, and dot products and closest point on edge and some of that cool stuff. So in case I wasn't clear last time, I want to do a quick revisit with the logical indexing thing. So we did some sort of fancy stuff before. I'm going to do the simplest example that I can think of. So over here in my system console window, first thing I'm going to do is import numpy as np. numpy as np, and then I'm going to create an array by arranging x equals np.arrange with one r, 12. Now x is this beautiful array. And now I want to generate a Boolean array. So I'm going to say this is a one-dimensional array. You'll notice that x is still just a flat set of values with one dimension. So we're going to say boo 1d equals, and then I'm going to do my logical expression. And I'm going to say, actually I don't need the square brackets. X is greater than 4. And now boo 1d, oh look at that, I have more than one possible entry there. Boo 1d is this set of values with false, 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 true, 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 because it's giving me the 5, 6, 7, 8, 9, 10 are all greater than 4. So now if I did x and I say boo 1d, then I get an array with just the values that are greater than 4. I can also skip the whole creating the reference variable thing by just putting the logical expression in as an index to the array. I'm going to say x, and I'm going to say x is greater than 4. And now it returns this array. And you can do that. If you want to make your code harder to read for some reason, and you don't want it to be easier to edit later, you can put in expressions like that. Or if you are comfortable just doing it because you want to make your code more succinct or whatever, it's a style thing. So I'll leave that up to you. Plus, maybe you don't want your coworkers to understand you, and maybe you want them to think you're like super, super, super smart, so you make your code really unreadable. You can do that by just putting the logical expression right in there instead of, yeah. So I guess I'll leave that up to you whether or not you want your coworkers to like you. Maybe you're self-employed, so it doesn't matter. Anyway, we talked about indexing all the z values with slicing. So x is currently this shape, but if we reshape x, we say x.shape equals 4, 3. Now remember, this boo 1d is one-dimensional, and now x is two-dimensional. So if we tried to index x with boo 1d, it's just going to throw errors because it doesn't know what to do with that. It's like, what, you gave me 12 values and you said access an array with 4 rows of 3? How do it doesn't know what to do with that. But if you reshaped your Boolean array, like you say boo 3d equals boo 1d dot reshape, and I think, I haven't used this in a long time, but I think it works like this. Oh, yeah, I spelled this wrong. Now boo 3d is the same shape as x. And now I can access x with boo 3d. 3d. Yeah. And you'll notice it returns a flattened array. And that's because I've got like 7 values here. 1, 2, 3, 4, yeah. And 7 is not divisible by 3, so it can't really return anything but a flattened array of values. So I believe, and we'll have to double check the documentation on this, but I think anytime you use a Boolean index to an array, it returns a flattened array. And depending on what you're doing, you can always set the shape again for some logical thing if you need to. But yeah, keep that in mind. A Boolean array is going to return a flattened array of values. If you wanted to index your X array, and instead of creating the one-dimensional array and reshaping it and all that sort of stuff, well, if you just start with your array that has this shape of 4 by 3 or whatever your shape is, then well, we're going to create this array. So we're going to say boo new, because it sounds cool, the boo new review equals this. Remember that X has a shape of 4, 3 already, so now boo new is going to have a matching shape. So you didn't have to create the 1D and all that sort of stuff. So that's just for review. Alright, now in order to be thorough, and also because this is going to be really useful, before I get into dot products, which I know you're all just like aching to get into dot products and Einstein summations so that you can throw those vocabulary words out at the next big party and everybody can look at you and go, ooh, ah, as you're being showered with gold dust for your new billion-dollar job. I'm going to talk about two functions that you need to know, which are related to this whole Boolean thing, which are np.any and np.all. And they work very much like you would think they would. One gives you all and one gives you any. And then we'll have to talk about axis also. So here's what they do in a nutshell. X is this array, 0, 1, 2, 3, 4, 5, in rows and columns. And I want to know, are any of the values in X larger than 7? So we're going to do np.any. And we're going to say, we can put a Boolean array in here, so we can put, boo new, which is, we've already checked if any of the values are greater than 4. So this is this Boolean array, are any of the values greater than 4? And it's going to say yes because we've got 0, 1, 2, 3, 4, so on and so forth. And it's going to say true. So you can also do it where you put the logical expression right into the argument, and maybe that'll make more sense. So we're going to say np.any, and then we're going to, this generates the Boolean array, but you don't even have to think about that if you don't want to, just think about the logical expression. And we're going to say x is greater than 7. And are any values in this whole array greater than 7? Well, 8, 9, 10, 11 are, so yes. However, if you say greater than 11, well, it stops at 11, so it's going to say false. And obviously this has a lot of potential uses that I can think of, and I will show you in just a minute. As soon as we talk about the sort of complementary function, which is np.all. Now, np.all is going to say, are all the values in X going to evaluate to true? So, are all of the values in this array greater than 11? Well, obviously no, so this is false. Are all of the values in this array less than 12? As a matter of fact, they are, so this is true. Now, to introduce you to the concept of axis, let's talk about transpose real quick. So there's a couple of different ways you could think about this X array. You could think about it as 0, 3, 6, 9, 1, 4, 7, 10, or you could think about it as 0, 1, 2, 3, 4, 5, or you could think about it as just a flattened array, x.ravel, which is 0, 1, 2, 3, So there's lots of different ways we can view this array and we can shape it. If you wanted to view the transpose, in NumPy sometimes you have to do transposes. You just do x.t. And this will output the transpose. So now we've got the rows and the columns have been switched. So now we've got columns of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, as opposed to rows of 0, 1, 2, and so on. When we use axis, it moves through the dimensions, starting with the columns and then going to the rows. So I will do np.any to show you what axis is doing. And this axis argument is actually used in a ton of other NumPy functions, so axis is extremely important to get familiar with. So here's x, we haven't actually changed the shape. Even though we hit x.t up here, all it does is just display the transpose. It doesn't alter x in any way. You could do x equals x.t and you could overwrite it, and then x would be transposed. But for now, x is still just 4 by 3. 4 rows of 3 values. And we're going to do np.any on x. And we're going to say x is, greater than, that's not greater than, x is greater than 2. And then, obviously it's going to say, yes, there are some values in here that are greater than 2, so it's going to evaluate to true. But what if we wanted to check every column? So I want to know, are there any values greater than 2 in this column? What about this column? And what about this column? Now, all of these columns have rows, or all of these columns have values that are greater than 2, and there's 3 columns. So if we did np.any and we do it on axis 0, so the second argument is going to be the axis argument, and it's going to be axis equals 0. It's going to check every column, and it's going to return an array with the number of columns that we have. So we're going to get an array of 3 values, and it's going to check every column and say, check every column to see if there's a number in here. Any of these values are greater than 2. Well, every column has a value greater than 2, so we're going to get true, true, true. So we've got this new array generated. For every column, there's a value that's greater than 3. If we change this up and we say greater than 9, well, the first column does not have a value that is greater than 9, so we're going to get false, true, true, because we're still using axis equals 0. So we're going to return 3 values, and we're checking the columns, and so now we get false, true, true. If we say greater than 10, well, the first 2 columns do not have a value greater than 10. It only goes up to 10 in this one only goes up to 9. So we're going to get false, false, true, and so on. Now if we wanted to check every row, like let's say we wanted to know if any of the z values were greater than 6 or greater than 0 or something like that on every row. Well, let's say any of the values for now, because we'll get to the slicing and z values in a second here. But let's say we wanted to know if any of the values on these rows were, for each row, were greater than something. So we're going to say x is greater than 10, and instead of the columns, we're now going to switch to the next way of viewing it, which is axis 1. And what we end up with is any values greater than 10 here? No. What about this row? No, 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 and so on and so forth. Well, we've got 4 rows, so we're going to get an array that's the transpose of the 0, 1. It's going to be, instead of 3 columns, we now have 4 rows that we're looking at. So we're going to get 4 values, 4 true false values, and only one of these rows has a value that is greater than 10, and it's the last one. So it's going to evaluate to false, 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 true. False, 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 true. Just like I predicted. I'm so smart sometimes when I've had my coffee and it's a good day. And I haven't just said that I'm smart, because as soon as I say that I usually do something really stupid that proves otherwise. Alright, so let's do this with all, just for the sake of thoroughness. np.all values are greater than 10. Well, it's going to say, and we're still doing axis 1, it's going to say false, 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 because none of these rows have all of their values greater than 10. Well, what about greater than, I don't know, 4? Well, hopefully you can see that. Let me just do it again so you can see it. All of the values in the rows, axis 1 rows, greater than 4. Well, these are not all greater than 4. These are not all greater than 4, but these are all greater than 4, and so are these. These are all greater than 4. That's the way this works. And remember how you can move through the dimensions of an array when you're slicing. by using the colon, and every time you put in another colon, you're referencing the next dimension. And so, like if we sliced x and we, x is this, and we say for every row inside of x, give me the first value, we get 0, 3, 6, 9. We get this first column. Kind of like how each colon represents a dimension. When you're using arguments with NumPy that have an axis, each axis, the 0, the 1, the 2, the 3, the 4, etc., moves you to a new dimension in the array. And so, like, numpy.mean uses that, and there's a ton of other functions that we'll get to that will use this axis argument to view different dimensions. So now, since we've talked about any and all, I'm going to do something meaningful with it. So over here we have the water, and we have Suzanne. And you'll notice Suzanne is actually under the water, and she's been under the water this whole time, and she probably really needs to catch her breath, so I'm going to give her a break. Whew, now she can breathe. Alright, so Suzanne is terrified of water, and she doesn't even want to touch it. So we need to figure out a way to keep her out of the water. Now, remember in one of the first tutorials I talked about how to get the coordinates, all the vertex locations, and here's the vertex locations, and we want to convert that to a NumPy array, and so what we need is this great big array that looks kind of like our X array that we love to play with, where you have n by 3 sets of values. So as in n number of vertices, in this case Suzanne has 507 vertices, and each vertex has an XYZ value. So we end up with this big, n by 3, where this is the X, this is the Y and Z, and so on. If we've already generated the NumPy array. I'll be typing. Well, we've created the function to generate the array full of vertices, but we're not actually calling it yet. So I'm going to say ob equals bpy.context.object. So, and that just means that that's creating a reference to whatever object is active. And you can make an object active by right-clicking on it or left-clicking on it, depending on if you have that user preference set. Anyway, if the object is active, it is what our OB is now referring to. And we're going to call our getCoordinates function, which turns all the vertex locations for this object into a NumPy array. And if you look at the accessing geometry tutorial, it'll show you how to build this, and it'll explain what it is. So co equals getCo, and our object. And now if we print co, I don't want to print all of them, so I'm just going to print like 10 of them. Then over here in my system console, oh, I put a comma there, it's going to show you the first 10 vertex locations. So now I want to do something to these. I'm going to start playing with any and all on these. So remember I said Suzanne wants to stay out of the water because when she was a kid she had this horrible accident at her swimming lessons where a guy dressed in a clown suit tried to drown her and she almost died. So she's terrified of water. And to get her out of the water, we're going to say, are any of Suzanne's z values below this plane that represents our water? Shouldn't it be blue? Or does anyone... I don't care. Maybe I'll make it blue for the next tutorial. Well, this water is actually at location 0, 0, 0. So to know if any of Suzanne's vertices are lower than this water, we just need to check to see if the z values of any of these are less than 0. And we did this in the last tutorial, where we checked the z values, but we're going to use any and all to do it this time. So make sure your object transforms are applied, because if this is rotated and all this, I can't remember if I mentioned this already, but if these things are moved around, then it's going to do weird stuff. It's not going to makes sense. If you're following along with the tutorial and your objects are scaled up or something or rotated, then you're going to get weird results. So just, clear your scale or apply it. I'm going to do Control A and apply location, rotation, and scale. And I want this plane to be flat, so I'm just going to clear its location and rotation and scale by hitting Alt. Let's see, is it Alt G? Yeah, Alt G to clear location, Alt R to clear rotation, and Alt S to clear scale. So now these transforms are applied. And if you want to move it around manually, go into edit mode and move everything, move all the vertices around. Just a note in case things are happening weird when you're trying to follow along with this. So remember, our active object is the one that we're getting. So if we have this as our active object and we print, we get the 4 locations of the 4 vertices in this plane. So we want to have Suzanne as our active object. And we want to check Suzanne's z values to see if any of them are less than 0, because remember, she hates water. So first thing we want to do is get the z values, and we can do that just by slicing. So z equals CO, and every row we want the second index, which is the z value. And if you print z, you now get this gigantic array with all of her z values. See, so there's all those lovely z values. A quick note, the way that I made this larger, if you go to Properties, you can set the font size. So that's why my system console is bigger. I didn't know that, so it was a helpful tip. So there you go, some free tips. Actually, all of this is free, so it's a moot point. Here's all of Suzanne's z values, and I want to check if any of these z values are below water. So print, we're going to do np.any, and we're going to say z. And we don't need to print z anymore. Now what I'm going to get is just a single value of, oh, I'm still printing this also. We're going to get a single value of true, because I didn't actually put a logical expression in here. We want to do z is less than 0. Yeah. Now we're going to get a single value of false, because none of Suzanne's vertices are less than z. But if we move her down, and now, uh-oh, she's touching the water and she doesn't like that. Uh-oh, now it's true. Some of her values are touching the water and she is going to have a nervous breakdown or panic attack, or start flinging bananas or other things that monkeys sometimes fling. We got to do something about this. So we're going to give her the chance to get out of the water again. We're going to say CO. And again, we can just overwrite what we slice directly. We're going to overwrite the z values. We're going to say plus equals, I don't know, 0.07 or something. Make her work for it. And we're adding to this array, we're overwriting the z locations of this array. And I talked about how we do addition, arithmetic, and multiplication and stuff in an earlier tutorial, so if you need to back up, then you can. And then we're writing it back to the object. So now she's going to move up by 0.7. Every vertex is going to move up by 0.7 on the z-axis. And it's only going to do that as long as some value in here is less than 0. As soon as she's completely out of the water, provided I did this correctly, well, I didn't actually write in the conditional yet. I'm just adding to this, so I need to put in my conditional statement here first. Okay, so my conditional statement is going to be, I'll just keep printing it, just so you can see. And we're going to say wet, which means that she's slightly in the water. So if wet, now move up on the z-axis. And is she still wet? Yep. Oh, she's still got verts that are below the water. She's still got verts that are below the water. And then she's getting closer. She's still swimming. She's screaming. She's panicking. And, oh, now she's out of the water. See? So as soon as this got higher than 0, now none of her vertices are below 0. So we used any to determine if anything was getting wet. Now, as Suzanne gets older, she goes to therapy and she is no longer terrified of water, but she's still terrified of drowning, because that clown actually held her under for quite a while. So she's going to, instead of trying to avoid the water completely, she just wants to avoid being completely underwater. So we're going to do, instead of any, we're going to use all. Now we want to know, are all of Suzanne's z-values below the water? Right now, you can see, obviously, all of her z-values are below the water, but she's not as terrified now, so she's just going to swim up so that she can get air. And it's going to say true over here because currently all of the z-values are below water. But as soon as just a single value is... Oh, excuse me. Burrito's coming back on me. As soon as a single value is above water, see that tiny little bit of her head poking up there? It's going to stop moving because it's now false. We no longer have all of the z-values below water. And Suzanne had a strange operation, or like maybe she fell into a vat of chemicals where she got mutated and she became like part whale, so she can breathe through the top of her head. She's like a monkey-whale hybrid thing that you wouldn't want to meet in a dark alley. So hopefully that makes sense. She stops as soon as this is no longer true. It's no longer true that all of the z-values are below water. And if we set this to something like 1, that would make a little bit more sense, because maybe she forgot how to breathe through the top of her head. Now, as soon as none of the values are below 1, she'll stop moving up. So we actually set our condition to be slightly above the water. I don't know, 4. Now she can actually get up to where she can breathe through her nose. Yeah, so 4 is obviously, 4 blender units ends up being somewhere around there. And now she stops as soon as a single vertex location, the z-value gets above 4. Hopefully that made sense, the any and all, and once again I'm skipping the dot product thing because this tutorial is already kind of long, so maybe I'll real quick make the next tutorial and I'll post both of them if we're all lucky and everybody has a good day and, I don't know, gold dust is falling from the sky and blessing all of us and whatever. I will talk to you in the next tutorial.